Let's take a look at these chemical equilibrium questions. The question reads, the reaction between steam and chlorine gas reaches equilibrium in a closed container according to the following imbalanced equation. Is this reaction exothermic or endothermic? Give a reason for your answer. To answer this, what we will need to look for is the delta H value. In this case, delta H is greater than 0. And if delta H is greater than 0, that means it is an endothermic reaction. Okay, 6.2, the graphs below, not drawn to scale, show how the amount of products in the container change with time at a specific temperature. The volume of the container is 5 dm cubed. Let's highlight that. Which reaction is favored? Choose from forward or reverse. Give a reason for the answer. So what we can see is that we have HCl and we have O2. Those are my products. And what's happening over time, normally the products would increase over time. But in this case, the products are decreasing over time. So that must mean that the reverse reaction is favored. So 6.2.1, the reverse reaction is favored. Why is the reverse reaction favored? Because the amount of products decrease over time. 6.2.2. How do the rates of the forward and reverse reactions compare at time t3? At time t3, let's take a look at that. So t3, we can see that the lines are parallel to each other. And when the lines are parallel to each other, it means that equilibrium was reached. And if equilibrium is reached, it means that the rate of the forward is equal to the rate of the reverse. So they are equal. Question 6.2.3. Calculate the equilibrium constant Kc for this reaction at this temperature if there was initially 5 grams of water and 5 grams of chlorine. Okay, so let's construct our table. First, we'll write our equation, 2H2O, 2Cl2, 4HCl, and O2. Now the table is a rice table. We'll put in our columns like this. R is the ratio, so this case is 2 to 2 to 4 to 1. Initial amount, remember, so in this case we'll use a mole table. So the initial amount is going to be, for H2O, it's going to be 5 divided by 18. So mass divided by molar mass. For Cl2, it's going to be 5 divided by 35, 70, 71. And for HCl, the initial amount we get from the table. So we look at HCl. HCl was 1. So we'll put 1 here. And for O2, if we follow that graph, O2 right here, 0.3. Okay, now the change. For HCl, we don't really know what the change was because the graph doesn't have any value there. Though we can see for O2, it started at 0.3 and ended at 0.1. So it decreased by 0.2. So the change for O2 will be minus 0.2. And then we use a ratio here. The ratio is 1 to 4. So that's going to be 4 times more. So minus 0.8. Then for Cl2, it's going to be half. So it will be plus, in this case, 0.4. And then here as well, plus 0.4. Now, for the equilibrium, we're going to have 5 over 18 plus 0.4. That's going to give me 0.68. For Cl2, it's going to give me 0.47. For HCl, it's going to give me 0.2. For O2, it's going to give me 0.1. Now, these are the moles. Remember, for Kc, we need concentration. So to get the concentrations, we'll divide each one by 5. because that was the volume of the container. So now the concentrations then are going to be 0, 136. Then this one will be 0, 0.094. This one 0, 0.04, and this one 0, 0.02. Now that we have the concentrations, we can calculate the Kc. So Kc is going to equal the concentration of products. Remember, the products are these. So 0, 0.04 to the power of 4 multiplied by 0, 0.02 to the power of 1 divided by 0, 0.094 to the power of 2 and 0, 136 to the power of 2. That gives me an answer of 3,5 times 10 to the negative 4. That is my Kc, 3,15 times 10 to the negative 4. That's my Kc value. Question 6.3. The pressure is now increased. How will this change affect the value of the Kc? It does not affect it at all. Okay? Remember, the only thing that changes the Kc or affects Kc is temperature. Next question, question 6.4. The reaction is repeated with a catalyst. Draw a potential energy diagram for this reaction and indicate the non-catalyzed reaction. Okay, so potential energy graph for an endothermic reaction looks like this. They wanted the non-catalyzed graph to be labeled B, and that means the catalyzed graph we'll label as A. Remember, when you use a catalyst, the only thing that changes is the activation energy, which is decreased. We represent it like this using a dotted line. So that is going to be A. Okay. And lastly, before we finish up, let's look at this multiple choice question. The reaction represented by the equation below reaches equilibrium. Which of the following changes to the reaction mixture will change its color from pink to blue? So pink is left side, blue is the right side. We want it to go this way, meaning we want the forward reaction to be favored. So how can we favor the forward reaction? Let's look at the options. If we add a catalyst, remember catalyst speeds up the reaction, it doesn't favor any reaction. B, place the reaction in a cold container with cold water. Would that work? Let's see. That would be decreasing the temperature. If you decrease the temperature, that's favoring the exothermic reaction. So it's actually going to stay pink. C, add a few drops of concentrated HCl to the reaction mixture. Now, we may not see HCl in the reaction, but remember, HCl dissociates into H plus and Cl minus. So if you add HCl, it is as though you are adding Cl minus. Now, what happens if we add Cl minus? If we add Cl minus, remember that is a reactant. Adding Cl minus means the system will want to decrease the amount of Cl minus by favoring the forward reaction. And favoring the forward reaction would then change the color from pink to blue. So that's the answer. Thanks for watching. I hope you found this useful. Don't forget to like, share, subscribe, hit that bell icon. I'll see you in the next one. Bye-bye.